Hey Steven, good
Hi,
to see
Maya.
you. I, I'm very happy to see you, and I'm very happy that finally we have invited you successfully to
Yeah.
talk to our students. And now you are the last master class of this week,
Hmm.
so we might be a bit tired,
That is okay.
but please take us as we are. And we are here in Zoom. Also, we are on YouTube.
Yep.
So you have 2 hours. If you finish a bit later, but sooner, that's okay. I will monitor the YouTube. So if we get any comments there, then I will let you know.
Thank you.
People here, if you have questions, do you prefer them typing the questions or should we just speak as we go?
For me, speak as you go. You're free to interrupt. If you have any questions, anything vague about what I'm showing you, or further explanation required, just raise your hand or interrupt to do something, and we'll address it immediately because it's going to be a bit of a hodgepodge of different topics. So it'll be interesting, I think.
Okay, so we speak as we go. People on YouTube can type. I will monitor that. And I think you can introduce yourself, that you know yourself the best.
Yeah.
But I can just tell you that you are an amazing artist, and I really, really respect your work and what you do. And I'm very happy that you have agreed to talk to us today. And we are. Uh, I will give the screen to you now.
All right. Thank you very much, Maya. Okay, so welcome everybody. My name is Jupijn. I am a virtual reality developer in the Netherlands, working in a small studio called Apollo Journey in Breda. Um, there, we work mainly with other businesses. We create training software, simulation software, and a variety of other applications, mostly aimed at training employees through different protocols. And we also work with VR arcades to build games played by the general audience. Um, Mainly, as I work for business, I work a lot with people who have never used virtual reality devices. A lot of people who have never used, even really played video games, sort of technological Luddites in some occasions. Um, so it's always been a very interesting challenge to see, okay, now we're dealing with virtual reality, a very new field of technology. How do we get these people engaged and how do we get them comfortable with this whole new experience? Because in the end, to give you an example, we work with firefighters, rescue workers, Dutch law enforcement. We work with hospital staff for aggression training, and a number of other um, uh, public institutions. And with VR, as a user, as someone who's experiencing the product, you are centric in that scene. VR captures the entirety of your visual spectrum, and it captures, if you're using earphones of some sort, the entirety of your audio spectrum as well. Um, this is extremely powerful, and it can hardly be overstated the amount of things that this enables your application to do and to engage with your audience on sort of an emotional level. So at work, I work mainly with the Oculus Quest 2, which I have right here. Oculus Quest 2 is both a standalone device as well as a virtual reality headset that can be coupled to a computer for more heavy rendering. But as it's on its own, we build mainly as a standalone device, primarily because of its portability. It being standalone, you have this thing in a little suitcase, little bag of some sort. You can take it anywhere, any get together, any entertainment sort of venue, anything that requires you to, hey, do you want to see this cool virtual reality experience? You stick it on their face, you give them the controllers, you either in the application or face to face, you briefly explain to them how it works, and they can get going. And if you see anyone standing around with this virtual reality headset on their face, that's going to draw in a crowd. For one example, one project that I ran at work was for a trade show for construction equipment. And a company approached us wanting to create a virtual reality experience of what it's like to be in one of these really, really big construction cranes. You probably know the type. They go up hundreds of meters into the air. Terrifying. I probably wouldn't want to be caught dead in one of those. But for general audience, the ability to experience this from the safety of, standing on the ground in this trade show hall is incredibly exciting. So they came to us and went, okay, we want to have the people being able to climb the ladder in some way to go all the way up to the top. And then they have to do something when they're up there. They have to do some activity that then forces them to engage with the environment. Because, of course, once you're up there, we have wind effects, right? There's like wind, the audio of the city will sort of slowly fade away into the background because you're now way up above it. There's birds flying around sort of to have some motion and catch your attention. And this big construction crane on top had a number of lights on it, the warning lights to protect against helicopters, and those lights had to be replaced. And this required a person to go about this entire top side of the crane and replace these lights. And they were done in a bit of a sequence. And the last one required you to go all the way to the very end of the long arm and then duck down, look straight through the metal, the metal bars at the ground that is, for your perspective, 100 meters down below. And then you had to reach down and carefully place the light. So that's an experience that basically I built by myself because I'm a technical artist, developer. I implement art, I do animation, texturing work, coding. It's a very small company, so I basically do whatever it is that needs to do or needs doing. We got feedback from the company that went to that trade show, and they said it was a tremendous success because there were people there at their little stand with a virtual reality headset on their head, screaming. And what better way to get the attention of people is when there's someone with a strange device on their head screaming really loudly and then laughing it off because they feel silly that they were so scared because, of course, there was no way you could actually fall. But it still captured them entirely. So that was a fantastic success. And that was one of my earliest projects that I ran at the company. And it was really one that really taught me very quickly the power of this sort of new technology. What I've done for this masterclass here is I've set up a little project in Unity. The project is available on GitHub. I believe that the link can be provided to you in some way, shape, or form. I'm sure that Maya can arrange something. I've sent it to Rogier as well. This project is free to use. You can grab it, download it, and basically once you have the project set up, you can get going in VR if you have a headset of some sort in the span of about 5 minutes. I really want people to get enthusiastic about working in VR. I think that it's a field that shows a lot of promise, both artistic merits and is what we're doing in teaching applications, aside, of course, video games and all that kind of stuff. And I would love to see, what people who have like great artistic insights can do with this new medium. I will share my screen and then we'll have a look at this little project. Just to go over some of the basics. Let's see, share screen, and then it is this one, go. All right. So welcome to Unity. If you've never used Unity before, it is a completely free engine. Everything that I'm showing to you in this video and everything that's included in the project is completely free, which I understand for students is a very attractive property. We're using various plugins. There are many plugins available for virtual reality development in Unity. For this one, I've picked something called XR Foundation and Interaction. These are 2 plugin packages that can be acquired for free via the Unity application. And basically, these include a number of very basic setups. They give you like a player rig to represent your player within your environment. They allow you to sort of pick things up and manipulate them. You can sort of throw things. It includes very, very simple and basic interactions that will probably be useful to you, in any sort of project that you do. The thing for this masterclass is, by the end of this, you're not gonna know how to set everything up by yourself. I'm not gonna go into very deep technical details because I need way more than 2 hours to really teach you how to do this. Mainly, I'm going to use this project to help illustrate some of the points that I'm going to be making, the things to think about when you're working in virtual reality. And then the project is here for you to sort of play around with, hopefully get inspired by, and get something running very quickly, so that you can sort of go through avoid the monotony of setting everything up, which is a bit of a technical involvement, and just get going and get yourself in a virtual environment as quickly as possible. So for the first point, we're going to be talking about movement in virtual reality. As this masterclass is called Caveats and Benefits, you'll find that everything in this has many pros and many cons. Movement is one such matter. So here in my little scene, we have the player rig. Now, it is represented by this green box and a number of objects here on the floor. What is very important to understand immediately is that in virtual reality, we're not dealing with one kind of movement, we're dealing with two kinds of movement. One kind of movement is the motion of the player in your virtual reality scene. This is the same in non-VR applications. When a user in a video game presses W or presses the up arrow, they will be moving forward in time and in space. This is something that you can do in virtual reality as well. However, in virtual reality, of course, with the fact that you have a camera on your face and you're moving around physically, there's the physical motion that you have to take into account. This immediately complicates pretty much everything you're trying to do, because now a user can, digitally move themselves next to a wall and then take a physical step to the side, and now they've stepped through your wall and they can see things that perhaps they're not meant to see. The experience breaks down because now they're seeing the backs of objects. They're suddenly understanding that the environment that they're in isn't real. It's all fake, and their immersion basically breaks down. So this is one major thing to immediately consider, like, how do you fight this? How do you deal with this? There's a myriad of different options, and I'll be discussing a few of them. So there's another issue that comes with the digital motion. When I use one of these controllers, right, and I press the thumb axis forward because I want to move myself forward further than physically stepping forward would allow me, because my play space is limited, obviously. The issue then becomes, okay, now my eyes are telling me that I'm suddenly moving, but my inner ear that registers G-forces doesn't feel a thing. For some people, this is okay. But especially in my experience with people that have never played VR games before, this can make people very, very nauseous very quickly. And in one case at work, got someone to throw up. I would assume that this is a consequence that you would like to avoid. However, maybe someone getting sick and throwing up has an artistic merit, in which case, great, go for it. It's really easy to achieve, but it's probably something to avoid. So we'll also be looking at how to avoid these kind of things. Well, I needed to go on to that point. One of the ways is, instead of moving smoothly through a space, you'll find that many VR applications use teleportation. Teleportation simply allows you to pick a point in space, aim it somewhere, and then you click, and then you're there. It can be a little immersion breaking, obviously, because maybe you're in some some experience with like jungle themes, and then suddenly you have this teleportation, which seems off. However, anything to basically avoid people getting nauseous. Another thing to do is, when you're moving a player forward in space, you limit their field of view, because when the field of view is limited, then suddenly the brain goes from I am moving to I am looking at a screen of something that is moving. And then the fact that the inner ear doesn't register the G-forces is perfectly fine, and the problem is basically resolved. When you're dealing with people who have never used VR, this is very important to get this right. You're talking about someone taking the headset off and walking away in the span of about 20 to 30 seconds, and they're done. Because when they get nauseous, everything else will fall apart. This is something we've really noticed in everything that we've built. If the experience isn't smooth, if the experience is nauseating, people disengage immediately. So definitely want to be looking at this and how to avoid this. Into teleportation, usually we apply something of a fade effect so that when you teleport somewhere, your screen fades to black real quick, you're there, and then it fades up again. It sort of helps to sell this transition a little bit better. So in this, teleportation is something that is relatively specific. It is something that requires quite a bit of a technical implementation to solve, because we have this volume, this green box, which is a representation of the player's physical space. This is basically the room that the person is in. You can kind of imagine it as. The player, the head of the player, is represented by this camera object. This is the object that will be moving around as the player moves their head around. We cannot move this camera because the camera's position will be set by the headset every frame. So if we try and move it, the HMD will just send its positional data, and then the camera will be snapped back. This goes for basically every single Unity plugin that I found. This is how it works. And it makes a lot of sense when you think about it, because if this is the player's representation in their physical space, we can't move the player around physically, right? Unless you're standing next to them and give them a hard shove, which is very easy because they're blind because of the headset. So, you know, it's a bit of a mean thing to do, to say the least. We can't move them around physically. So instead, if we want to move the player, we move the entire room that they're in. We do it like this. We simply move the volume that they're in, and then they'll move along with it. Now, of course, when we're teleporting, we want to make sure that the player ends up exactly where they aim, right? So if let's say the player has moved to a corner of their room and his head is like up in the air because he's not laying his head down on the ground, I would imagine, and they want to teleport somewhere over here, we can't just move the entire volume exactly to the point where they want to go, because in that case, they would end up with this offset between to where they actually want to end up teleporting and where they'll actually appear. So instead, what we do is we have to move the entire volume as if the pivot is the player's head. We then take the Y offset into account, and then even worse, when we want to then rotate the player, because your teleportation, they might want to end up facing a different way, we have to rotate the entire volume around the player camera like this, because obviously if we don't, then they're going to have that weird offset again. So teleportation is a bit of a multi-step process. Fortunately, what I found is that this XR Foundation, the XR Foundation rig has a couple of helper functions already built inside of it to make this process a little easier, so that you don't have to get into the matrix multiplication math and the other sort of setups you can do to make this process a little easier. It's all done for you, so nice and easy. Right, so movement is a whole thing immediately upon itself. The benefits, a player wanting to take a small step forward, you don't have to teach them that. If they're an adult, they can walk, so it's completely intuitive. However, you are dealing with the fact that the player has a limited physical space. You're dealing with the player being able to potentially step through some of your environment geometry and then breaking the illusion. So definitely pros and cons. One quick solution to the idea of a player physically stepping through a wall. There are a couple of games that do this already. One way is to create a collider around the player's head. And as soon as they touch some level geometry, you check the collision point where they hit the geometry, and then you push their entire volume backwards slightly based on that direction. So whenever you move towards the wall, you just get shunted back. This can work. In most applications, it works very well. You can otherwise also blind them, right? If they stick their head in geometry, you just blind them until they move it back out. There's a number of different solutions you can do, but definitely something to consider because VR is all about immersion, and breaking that immersion with something relatively simple would be very regrettable so quickly early on. Finally, with virtual reality, we're dealing with one of the most natural input methods that are available to us. Picking up an object is something that can be done entirely intuitively, especially with this. We have this Oculus Quest controller, We have a little grid button here on the side, as it's called. I hope that the camera can kind of show this, this little button, which is basically if you're holding the controller as normal and you squeeze your fist, that is the button you'll be pressing. So if you tell any user, no matter how inexperienced they are, that they have a virtual hand and there's a little cube, and you tell them, hey, can you pick up that cube? They pretty much immediately know what to do and what it's useful for. And then they figure out how to throw something, they figure out how to manipulate something. It all goes very quickly and very naturally. This too is a very powerful thing, definitely a benefit of VR, but there is a caveat, much like with everything. When a user expects things in your virtual environment to behave as they do in the real world, they gain this expectation, meaning that anything that now breaks that expectation will cause a negative experience because they expected something to work a certain way because that's how it works in the real world and with the interactions that they have available. And then when it doesn't, they are left sorely disappointed. So when you're building these interactions with all these different systems, you have to think very carefully about what do you represent, what do you pull over from real life, or what do you not. Fortunately, what we have found, and this is quite nice, you get a lot of mileage out of virtual reality. Like the example with the crane. When you're dealing with, let me just reset this real quick. When you're dealing with people that have never used VR before, they're going to be intrigued by just about everything, right? They're going to go into your application. They're going to think, wow, I'm really in this new, virtual environment. This is new and exciting. I want to explore everything. We've built experiences where we had a little room that they were in, and we had like a drawer, and we had a cabinet, and we had some other little bits of furnishings. And we've had players who just spent 20 minutes opening every drawer and opening every cabinet, everything that could be opened that might have something of interest in it. They would look at it. I think at one point, one of our environment artists stuck a little sticker to the bottom of a table, just as like a little fun prank. I don't think he even told us about the fact that he committed that originally. And it was a sticker that simply said like, little nosy, aren't you? And then as soon as you put that into that thing, and then a client eventually discovered it, they ended up turning the entire virtual room upside down to try and look for more secrets, which was a wonderful experience, of course, because if you can justify spending 5 hours of development time on this room and then getting, I don't know, like a full half an hour of experience for most users out of it, that's fantastic mileage. One very big benefit of working with this very new technology is that the technology by itself is very exciting. So let me see if I can get this going, because I've built this little default environment to sort of put in some very basic elements of the XR interaction toolkit, and I'll see if I can show you those. Just gonna have to see if my connection is working. The nice thing about this as well, if you're interested, these devices are relatively cheap for for a full virtual reality headset, and they support something called linking it to your computer. You can either do this through a cable or over Wi-Fi. When it is linked to your computer, it basically works as a regular cabled headset, meaning that I am completely wireless, but I still have the rendering power and capability of my desktop computer, which will simply stream all of its data back and forth between my headset and the device. And for the most part, this has worked absolutely wonderfully. And if you're interested in getting started with developing for virtual reality, then I can recommend this device. I know I'm sounding like a terrible shill right now for Oculus, and Facebook is definitely doing certain things in the background that I'm not entirely fond of, but as a piece of hardware, this has been very, very impressive. In my job, we build mainly for standalone because this runs Android. So if you can build to Android, you can build virtual reality experiences. We mainly use it in that, in that way because, again, the portability is huge. However, lately we have started delving more into this whole link stuff and seeing if we can leverage this in still relatively portable solutions, but at the same time deliver, desktop level rendering. Because, of course, this being an Android, essentially a phone, a very, very high power phone, its rendering is obviously limited, right? So let's see if this will work. I believe it should. Yes, it looks like it. Right, so you should be able to see what I see. I can now, I have my hands here, and I should be able to move about. Yep, I can move and walk and everything looks like it is working. So in this, I have implemented various sorts of elements of the VR interaction toolkit, just as a very basic, first time demonstration on how this all goes. So I can pick these up with this little grip button, sort of do with it whatever I want. I can throw them. This is all part of that interaction toolkit. This took me no code to set up. This took me no real effort. You just slap some components on your hand object and you're basically good to go. There's also UI interaction in this. I think it is the right key. Yep, I can press that UI button. Virtual reality and user interfaces in Unity, they often don't go well together, but the XR interaction toolkit actually has built-in methods for playing around with this. So just as a very quick early demonstration about the various things that you'll have access to in this package pretty much immediately. Oh, this also has my own teleporter integrated. The XR interaction toolkit, I think, also comes with its own teleporter implementation. But I had one lying around. It was just literally a package that I built a long time ago for myself that I could just import and get working. So I decided to stick my own little teleporter in here. Teleporter is, you simply have a, let me see here. You have an object on your hand. It shoots a ray, in this case, a ray with gravity. These spheres show the points that it is registering. And then as soon as it hits something, it'll give you back a validity check. And if it's valid and you let go of the key, it'll teleport your rig over. The teleportation, I think, at the base does use the XR rig in built-in movement functions, which is very, very nice. And as far as I found, very accessible. Because I understand that, most of you will be artists. So the less code you really have to work through, the better. So there are a number of sort of helper classes that I've built to sort of help you avoid the huge amount of code that runs behind everything. Let's see if I can actually grab one real quick. Let me see. So we're going to be looking at a tiny bit of code just to show kind of how that XR input setup works, and a class that I've written especially for this project to try and make it a little easier, because I found that the XR interaction toolkit, the way that it gathers its input from these devices is a little, I found it a little strange. I understand why they're doing it, but it was a little bulky, if you will. The amount of code you had to write to get a simple input was a little much. So in the end, I decided, okay, I'm just going to write a little player input handler class. The player input handler, it looks big and it looks kind of maybe like, oh, that's intimidating, but it is very, very simple. It just gathers values from these features that these support, and it throws back a bunch of events based on if something has changed. So for example, if we look at the primary button, which will be the A key on the right controller, it'll simply throw either if it has been clicked, if it's been held this frame, if it's been clicked this frame, or if the click ended this frame. And you can access all these events and hook up whatever functionality you want to it. For example, the, let me see here. Let's see. For example, when the axis changes, meaning I am moving the thumbstick on my controller, this function will simply take that axis and stick it into a variable so that we can then handle the movement based on that input axis and handle the turning based on an input axis. It's all very, very simple. This code isn't commented. I had to do all of this, sort of in after hours. I have a full-time job at a VR studio setting that doesn't leave you a lot of time to build your own sort of experiences. So I've built this up real quick. It isn't terribly well commented, but the code is relatively simple. So hopefully just by looking through it, you'll be able to vaguely understand what it does. But overall, I try to keep everything as simple as possible. In the GitHub README, there are also, I've linked a number of resources that I've used to construct this little project. I found a YouTube video series that basically goes step by step through the entirety of the XR interaction toolkit. So if you want to set this stuff up by scratch and use the XR interaction toolkit more than I've done, because I've built a couple of implementations that sort of circumvented some of the more complicated matters, you can definitely just follow along with those tutorials. They're very user-friendly, and much like the rest of Unity, it's all, you know, this engine has been out since, I think, 2005, and it's been perpetually improved since then. And the documentation, as well as the user base, is huge. So working in this, there will be someone who have had a question you've had before, and you've been able to look it up and find the answer and dig through documentation and basically find whatever it is that you need. So hopefully for your next artistic project, you'll see the benefits of VR and consider using this setup. So let's see. One of the things we do most in my work is building multiplayer experiences. Virtual reality is a very lonely sort of thing, what we found for the most part. You know, as soon as you put on the headset, you're essentially isolating yourself, right? You cut yourself off from the people around you, much like, oh, you're going into public transport, you know, stick a couple of headphones in, you can kind of forget that the world around you exists, which can be nice, but especially in this day and age with these kind of experiences having become more community driven, multiplayer in VR is, we found, has the most incredible sort of effect that we've seen immediately. As soon as someone joins a multiplayer game and then another VR user joins the same session, and we've done this with, for example, the firefighters, because they have to train their exercises in teams and divide their roles, like who brings the extinguisher, who pries open doors, who does the thermal camera checks, who does, you know, all this kind of stuff that they've been teaching us about. If they get into the game and they can look at each other and wave, that by itself has already immediately gotten great effect. We've seen people, you know, they go, it binds them so much more, because they can still talk to one another as long as they don't have like earphones in. They can speak as normal, but they can wave each other in reality. And this immerses them deeply. Even people that have never touched VR, this is again a very natural process we found. These firefighters, we're talking about men and women who are, you know, 40 to 50. They can write an email, and that's about the extent of their technological prowess in some cases. Not for all of them, obviously, but for many that we've spoken to and educated. And their experiences have been invaluable. Every time they bring someone new to test out the stuff that we're working on, we very closely monitor their experience. And if anything is confusing to them, or anything is overwhelming to them, or they get stuck, or they become too busy with the technology instead of the experience we're trying them to have, we make notes of this immediately and start writing this down and start thinking, okay, how do we make this more intuitive? Because again, a caveat of VR is that the technology is very exciting. It can also be too exciting. People get really wrapped up in you know, being in VR and having this headset on, having these controllers and all this stuff to do. And while they're going through all of this, while their brains are sort of dealing with all the new stuff that they've been given, they completely ignore the stuff we're trying to teach them about, you know, the actual experience they're about to do. So we found that giving people a bit of a slow start, a start wherein they can sort of do whatever they want, help get that energy out, help get that initial curiosity satisfied before we engage them with what we want them to engage with. We found that to be very beneficial. So if you're building an experience of your own for a crowd of people that you know will probably be very new to this, it is wise to, at least if your experience allows it, because you maybe only have like a minute per person, giving people the room to experiment a little bit before giving them more pertinent information about your experience is definitely very beneficial. Let's see here. Right. So for this, I was thinking about, okay, so I'm going to be giving this masterclass. I'm going to be talking about, all this kind of different topics and aspects. But I figured, well, it'd probably be nice if I implement something specific, something that can only be done in virtual reality. Because for any project that you're going to run, we do this a lot with clients that approach us where they have ideas about, hey, we have this cool idea. This is what the idea should do. This is the function of this project. We'd love to do it in virtual reality. There are some cases where we've talked clients out of doing it in virtual reality because virtual reality development is hard. It comes with a lot of caveats, as is evident. And if we don't see the benefits, if we think like, okay, you really want to do this in VR, but it makes things more complicated and it doesn't add to your goal, we will talk to them. Of course, if the client is dead set on using VR, okay, client gets what they want, but there are cases in which VR isn't right. But in order to figure out if it is, if you're building an experience, really think about, okay, what can VR do? What can the player do, an experience that is impossible in another medium, right? If we're just dealing with a screen, you have a mouse and a keyboard, what can you do? What can't you do? And what can VR do? Now, there's a number of different things. One of the things, of course, is that suddenly we're dealing with 3 dimensions. Now, of course, if you played any sort of first-person shooter game or any game really modern, you think, okay, 3D has been out forever, but there's a big difference because now our input is 3-dimensional, right? With a mouse, we have an X and a Y where the mouse moves over the screen, but in virtual reality, we have a Z. We can move the controller away and towards us. So I figured, well, what can I build that sort of helps, play with this and present something that is new that you can't do on a regular computer. It's a very, very simple little setup, and I will just very quickly show you what it looks like. The system behind it that I've written is quite a bit more expansive than the functionality that I'm about to show you will display. But there's a good reason for this. It's primarily because this is, of course, an example. But the system behind this can be expanded massively, and I'll go over that as soon as I've shown you. As if my Oculus Air Link wants to connect, because it says it isn't connected and it needs to go ahead and connect. And I would be very appreciative if it could do that. So let me see. Oh, there it is. Okay, connect again. And then load it in. Yep, all right. So applications like this exist already. They exist in various different forms. The reason I've written my own is because I would love it if you look at this project, if you play around with it, and then eventually maybe even expand on this system. And what I can do now is basically, oh God, I hope I can, because it isn't working. You'll see that right now it breaks. Oh, that's the teleporter. That is good. That still works. But is my thing going to work? Nope, it isn't. Okay, hold on. Let me check real quick. Of course, now it breaks. I just restarted real quick to see if perhaps the device wasn't connected. No, it really doesn't. Wow, that is a shame. Oh, but it is creating a new painting. That is very. Oh, wait, no. Oh, I see. There is we're getting a null reference. Let's see where that is happening. Well, you're gonna see some live some live fixing. Apparently, I'm missing an input somewhere, and I think I know where. Let me see, paintbrush. Oh, that'll be in the. No, it definitely is there. Well, we're going to be doing some live debugging here real quick. I hope I can fix this very, very quickly. Oh, the brush set is broken. No, it's definitely in there. Let's see, strokes as well. Yep. Interesting. This should really be working at this point. I am very curious as to why it isn't. Oh, this was working just a moment ago and now it breaks. Maybe I've changed some sort of prefab in the background and I forgot to fix something. Nope, it's still giving an object null instantiation. Right, so player input handler that goes to painting controller. Yep, it wants to add the thing. Then it wants to add the brush stroke. And then it's going to paint manager. It's going to instantiate this prefab. And apparently this is null, and I don't understand why. Let's see here. Oh, there it's missing. Ah, okay, I found it. So I'm gonna go to prefabs, brush stroke. There we go. Okay, now it should be working. Of course, it has mildly spoiled exactly what this does, but you might have guessed. Oh, is it still not working? No. Oh no. Why is it not working now? Oh God. Okay, I really don't know what happened here. This is starting to give errors that I have not seen before, and I don't know what's going on. Well, I'm just going to talk through it real quick. Maybe we'll have time later on in this presentation to see if I can fix this. But for now, essentially, we have a little dot and you can draw lines in 3D. So you can basically create 3D paintings. That was sort of my concept for, a very simple little system that allows you to do something that, well, at least on a regular PC would either be very difficult or at least very unnatural to do. It's a real shame that it doesn't work for some reason. Index outside of your array. What are you talking about? It's being silly. So it definitely has everything that it should need. So I don't know why it's failing. Oh well. So being able to paint in 3D, there's a system behind this that basically allows you to serialize all the data that you're generating by painting. For those who aren't aware, serialization is essentially you're taking the data and instead of having it being a bunch of like pointer references to different spaces in your memory, which is something that isn't transferable, it becomes data that can be saved to disk. Or in another case, is data that can be sent across a network. So one of the imaginations that I had is if you expanded this this system, which is a sort of standalone little thing called 3D Paint, you could do communal sculpting, right? You could put multiple people in a virtual reality environment in multiplayer and have them create some sort of environment together based on these little lines. You could draw a singular flower with a number of brushes in different colors, and then you could take that flower, save it as an object, and then duplicate it a bunch of times to make a bouquet. And then you could take that or make a patch of flowers with some grass and some other flowers around it. And then you could litter the ground with that. And I think slowly over time, you could be basically essentially building an entire environment out of 3D lines in a way that other people can then experience, because you could then save the entire environment to go, okay, this is, forest. Go in and let people walk through this, let them explore this, let them sort of deal with this and see what they would like to do. You could build an entire virtual reality a museum, for some example, and just show different kind of sculpts and different 3D drawings that people have done. Another thing that I thought about is we're tracking the motion of a person, obviously, with the headset and the controllers. If someone were to perform a dance of some sort with this device on their head and the controllers in their hands, if you were to draw every line that they're tracing, you can generate a 3D sculpture that represents the motion of a dancer of some way. And then someone could either trace after it or just explore it in space, do various things with it. I don't know, that is eventually for definitely the more artistically inclined to figure out exactly what they want to do with that. But the system that is in here is, it's a simple setup, but it's very, very expandable. You have a paintbrush and you have a paint manager. The paint manager has a number of brush sets that you can create. You can just create entirely new brushes in this. The only thing that this project doesn't have, which is a shame because it's something that I wanted to build, but I sadly didn't have time for, is it doesn't have any sort of user interface to switch brushes and switch, different settings on the fly while you're working with this. That's definitely something that I would love to add and give people more opportunities for, making different kinds of brushes, making their own brushes. And sort of all toying and playing around with these things, much like you would do in something like Photoshop or GIMP. But like I said, applications like this exist. However, now you sort of have a very basic rudimentary version. You have access to this. Maybe you would like to pick it up and expand it. Like I said, all the code that's in here, written a little bit in a hurry. It's not the cleanest, but do with it what you wish, expand it, make it your own, read it through, improve it where you can. I'm sure there's lots and lots of room for improvement. But you can essentially consider that you can just do whatever you want with it. So definitely,
Sorry, could I ask a question?
Absolutely.
You said that you can make something like the sculptures and we can painting. But I don't know, we can control the pressure of how much we can press, something like, the digital pen?
Yeah,
when you use
absolutely. The Oculus controller, of course, it depends on the VR headset and the VR controllers that you're using, but most of them have input strength. These are even one step further. These do not only register when you're clicking them, but they also register when you're simply laying a finger on the button and just touching them. They have capacitive touch. But yes, there's a trigger button. I hope it's visible. This one on the front, and it is a little lever action. So it'll detect exactly how far you're pressing it. So you could absolutely create stroke weight, 100%. You could attach that value to anything. You could say, the harder I click it, the more the points should disperse around where I'm painting. Or when I click the button, when I click it softly, it should be this color. When I click it hard, it should be this color. Go ahead and blend between those as I go. You could do a ton of different things. Another thing that I was considering is, right now, you're having a paintbrush with a single tip. You could say, well, instead generate me a cloud of paintbrush tips and then have them orbit around a central point so that when I move my hand and paint a stroke, you're getting these sort of orbital lines that vaguely follow after where you're going. You could then add smoothing to that so that the paintbrush tip follows after your hand more gradually, so that every line that you draw will be very smooth, and you could do all this calligraphy stuff. You also want to do you could do straight lines. You could just click in a point in space and then let go and then put it somewhere else and click again, and we just make a straight line straight between the 2 points. There's a huge host of different things you could do with this, and I'm really sad that for some reason it isn't working, and I would love to get it working because it'll give you some idea of what it looks like. But I have apparently messed something up while I was working on this today because yeah, it doesn't want to. It didn't want to do its thing for some reason, and I don't understand why, because it should have everything it needs. Maybe we can spend a minute or two just trying to fix this, because it would be nice. And then I'll continue with some more matters about interaction and some of the experiences I've had, and looking at a project that I developed for myself, or at least started developing it. It was never finished, but it was a very interesting VR experiment. Having to do with many of the things that I've already talked about, but we'll get to that in a moment. We should have enough time. We still have, yeah, we have an hour, 10 minutes left. It should be okay. I'm just going to see if I can get this going, because it would be nice. Hopefully, it'll give you a better understanding of what this looks like. Let's see. Okay, connection is going again. So there is a. So can't find the. Oh, wait a moment. Let's see. This might be a race condition, in which case it would make sense that it only shows up now and it didn't show up previously. Let's see. Let's see if it works now. Nope, still doesn't. Oh, I'm very, very sad. Well, this is you're getting a real-time look into developing for VR. It involves a lot of sitting with a headset in your hand and wondering why something isn't working. Oh, now it can't find the settings object. What is going on? This is very, very strange. Oh, wait a moment. There's 2 paint managers in this. That is not supposed to be the case. That would probably explain it. It generated an extra paint manager for some reason. And it found the wrong one. And it found one that doesn't have any of the settings that I gave it. There we go. Okay, so now I can draw these fancy little lines. in VR. And the nice thing is, of course, because we are in 3D, they are entirely volumetric. So you can turn around these, you can do with them one-to-one. The nice thing also is when you're creating a painting like this, it generates its own painting object. So everything is stuck under here. So when you're you can move your painting around. I would love to add further control so you can pick up a painting, scale it, rotate it, sort of put it wherever you want and create new paintings. Right now, everything you do is just generating on the same painting. So let's see if it didn't like, oh wait, hold on, is it because this isn't the focus? Nope. Okay. So of course it doesn't save anything yet. There's no saving capability in this at the moment. So right now, once you've created the painting, you stop the application, the painting is sadly gone. However, the data set that supports all of this under the hood is something that can be very easily saved to disk and loaded. So you can kind of play around with this. You can go and just draw like little, very rough 3D cubes. You can even like color in different faces. And because we're dealing with these brush sets, if we go to our painting manager, we go to our current brush set. In that brush set, we found our brush default. Let's say we want to, because of course this is something you would need to build a UI for, so the user can do this themselves. But let's say we want to go from blue to white. And let's say we want to do like a weighted line. You can just edit this, and then now you're drawing a completely different style of line with the stroke weight, as you can see. However, this doesn't respond to my input. It's just a fade, so it goes from thick to thin no matter what you do. But building in the variable thickness would be something that is relatively easy to do. So again, this kind of artistic work, if you can call my incredible multicolored scribble, is something that is simply not feasible in current, technology applications outside of VR. So that's kind of one of the reasons why I decided, okay, I'm going to build a simple little painter system. I think it took me about one full weekend of coding. I'll very quickly go over the serialization aspect because I think that's very interesting for any artist. Not being able to save your work is pretty rough. I saw that in the talk from yesterday. There was talk about how to conserve sort of these artistic things. So all the data involving your emotions and everything you do and the colors that you place and the points that you're placing in space is all saved in its own little data classes. All of these can be serialized to disk. So you could write functions that say, okay, you've done a painting, go ahead and save this painting to disk. You can just run through all that data, gather it all and save it to a file. And then you could say, okay, now go ahead and load a painting. And then you'd be able to load it, place it in the world, duplicate it, rotate it, do whatever what you want. The entirety of the data exists within local space, as it's called. So when you have your painting, you're drawing on the canvas, everything you're doing is within the painting's space. And then if you take the painting and want to put it somewhere else, that's no problem. So I've really tried to make it in a way where thinking about art students and thinking about how they might want to represent their work and build this system in a way that allows them to save this and share it. And maybe at some point someone will go, I want to make a multiplayer version of this. I want to start sending it over a network. I want to save it in a database. I want to be able to just load it up and do whatever. With the portability of a Quest, you could do this completely standalone as well. Nothing of this is necessarily, it requires a beefy desktop computer. So you could take a headset like this, simply connect it to Wi-Fi, make it connect to some sort of server or database, let people draw whatever they want, let them make little sculptures and things. And once they're done, you can just go ahead and save. And then now you're building this repository of interesting 3D sculpts and things to do with as you wish. So that's a little painting system that's in this project. Again, completely free for you to do with what you wish, make it your own, make something cool out of it. Make me very, very happy. And otherwise, hopefully it'll inspire you to maybe build something even better. Because like I said, I only spent a weekend on it. Maya, I do have to ask you very quickly. Is it okay if we take like a very quick 5-minute break?
Yes.
Because I've been going a mile a minute. I just need a quick 5 minutes and then I'll be back and we're going over some of the other projects I've done. I have some small like presentation videos and things to go through. And then we'll also have some time for questions and things. So I will be back in 5 minutes.
Okay.
So people can just hang around. Apologies for the interruption. Back in a moment. Okay, there we go. Apologies for the momentary interruption. Right, assuming that people are here. Let's see, it's been 5 minutes. Okay, so let's see. So with the painting working, one of the things that I considered quite a while ago, virtual reality has interesting applications for fields like architecture. I worked for an architectural company for a while, did basically pre-visualizations for apartments that were not yet constructed, but were going to be constructed, and they wanted to get better insights on how things are going to look. You may have seen the artistic renders of, not yet constructed buildings to help give people an idea. But in virtual reality, you can really place them in the room, make them able to feel the space, feel the scale of things, sort of see their sightlines. Because of the way that virtual reality transfers to our eyes, the field of view that we're using for objects has to match reality pretty closely. So things like distances and scales of things will look pretty convincing. So one of the things that I did in this case for my mother, who's moving to a new apartment, is she really wanted to know, how is the sun going to move through my apartment over the summer and the winter? She was really curious. She loves the sun. I mean, she really wants a light apartment. So I built this little visualization for her that sort of is a render of how the sun moves over the summer, based on longitude, latitude, north, south, the time of the year. It sort of did everything. And it gave her a really nice idea. Then, of course, well, given the fact that I now have this 3D object, I might as well also stick it in virtual reality. And then, even though her apartment isn't built yet, she was able to walk through it. And she loved this entire experience. She was incredibly excited. It was nice to see that even simple things such as this, just the ability to put someone in a space is by itself already quite powerful, something to do with. So before this, I started thinking about, okay, well, if we're taking the entirety of a person's view and with headphones, an entirety of their ability to hear, what if we start taking this away? What if we create an experience that makes someone understand, like, okay, what is it like if I have to navigate in a way that I'm not used to? So what I constructed was a little sort of demo project that ended up becoming a little bigger than I expected. I'll go to mute this audio a little bit. So this is an old project. I only have a few videos of it. I can't show you how it worked in VR, so you're just gonna have to trust me on this, I guess. But essentially, what this project aimed to do was your vision was limited by these sort of fake light pulses that you could generate. And they would give you a brief, glimpse of your environment. You could sort of run after them and go. And this was a very early iteration of that system. Because this application I built for the Quest as a standalone, I couldn't use any real sort of lighting, because doing real-time lighting on Android is a pretty significant ask, and it basically kills the rest of your rendering budget. So if you wanted to do anything else but dynamic lighting, you're gonna run into bottlenecks pretty quickly. So I had to figure out, okay, what kind of clever shader tricks can I use to create this sort of effect? So what we're seeing here is when the user creates a light pulse, or in this case, many light pulses, the audio of the pulse is put to wherever the player is looking, and then at the distance of the pulse, so that they always get a feel that like they can hear the pulse moving away from them. And it illuminates their environment. So playing with this, I need to do some optimization. This is a very quickly technical look into how that works. Essentially, when you're creating a pulse, every mesh that has to receive and display that pulse duplicates itself and renders an additive version of itself on top. This way, I had a single shader that simply handles a sphere mask. A sphere mask is just saying, hey, take the world position of a pixel, see what is the distance of this pixel to an arbitrary point in world space, and then set the pixel to this value, to this distance. And once we have a distance gradient, we can then animate a gradient running along that distance gradient. So this gave me an incredibly cheap way to generate these sort of pulses. Because they're additively rendered, they don't Z-fight, they don't have issues with themselves, because their rendering order doesn't matter, because A plus B is the same as B plus A. And these little boxes simply show the amount of meshes that are being rendered in that spot to sort of support these pulses. And as you can see, if a pulse is never going to touch a mesh, because once you create a pulse, their position is static. That mesh doesn't have to be duplicated. So this entire system basically handled itself. Once I created all of this and started experimenting with it, was like, okay, now I need like some interaction. And I came upon the idea of like, okay, well, there needs to be some sort of threat. We're going to turn this into a slightly horror-like experience. The idea of horror where, you know, you're more afraid of something you don't fully know or don't fully see is very powerful. And given the fact that this was a project in which I took someone's sight away, I figured that would be a natural fit. So the enemy in this little red guy, is an enemy that stands completely still, and they can only move when the light pulse moves over them. When I built this, the response that I got from some colleagues at my work was terrifying. They hated this. They were like, "Oh, I don't want to play this anymore." In the later iteration, I'm really sad that I can't show you the final version of the project before I decided to move on to other things. But the enemy made like an ambient sort of breathing noise, so that even in complete darkness, you could kind of know where it was. If you bump into walls, you make noise and it will come for you, even though you can't see it. So you can just hear it grinding along the floor. It made like a stone grinding noise whenever it moved. When you had your controllers and you move them outwards, if your controller gets near a wall, you'll get haptic feedback. So your controller would start like vibrating very likely. And then if you rub a wall, the vibrations would change. So it would allow you to sort of feel out your environment. And yeah, experimenting with this, I was like, okay, this is pretty cool. This is getting a visceral response from people. I had to start doing the design work on this enemy and make it look horrifying. I needed to add like a state of like, okay, if the enemy is really close to you, it'll just get you. So I needed something for that. Eventually, I started playing around with the idea of creating a lure. Like maybe you can have like a little ball that you can throw and it'll create pulses constantly as it rolls. And then the enemy will basically go after it. So you have to figure out, okay, the enemy's sort of there. This is my lure. I'm going to roll it. Hopefully it'll roll past the enemy, so it'll chase it. And then I can go somewhere else and do something else real quick, you know, and take care of something. That was essentially the end of my design process. It was a lot of fun to build from a technical standpoint, as well as a design perspective. I still think there's an idea here, like, hey, you could do something with this, create a little, like, you know, 5 to 10 minute horror experience of someone having to solve a puzzle while this thing is in the room. The idea that the thing can only move if you create a pulse, it gives the player a lot of control over what this enemy is doing. So it gives them a sense of control, but at the same time, if you want to see anything and know where the hell you are and not get confused, you have to create a pulse, at which point you know, once that pulse reaches that monster, it's going to be moving for me. So it becomes this interesting trade-off of a player. And in terms of the virtual reality experience, you know, this being having your vision entirely taken away and only giving you brief glances was very, very effective. Then using the directional audio from this thing grinding when it moves and making this breathing noise and all these sonar noise that sort of always moves away from you. It's created a very interesting soundscape that really helped ground the player in the environment. I did find, however, that taking a player's vision away entirely was perhaps too much because in my experience, the people that tried it, they got more frustrated than they were engaged with the limitation. So it became a very interesting design constraint. Like, how do you reconcile these things? And I ended up not having the time to really explore these matters and really dig into them and sort of solve these issues. So eventually I ended up like, okay, interesting idea, maybe something fun for later. I'll keep it in my head, maybe think about it every now and again. But I'll leave it behind because I have other stuff that I want to build. So this little sonar project that I ended up calling it ended there. But it was a lot of fun. And it was one of those things that really taught me that the fact that you have full control over what someone sees and what they hear, as well as having the haptic feedback from the controllers, are things that they're easily missed, in some cases more than others, of course. I even found that the idea that if you're in a game, you can't see anything, and you want to turn, let's say, 90 degrees, that's very difficult to do with your mouse, to turn 90 degrees, because you don't know how fast you're turning. It's something that you really have to learn. But in virtual reality, if you tell someone, can you turn your head 90 degrees to the left, everyone will be able to do it. They'll know exactly where they're looking. So being able to retain the places of objects, even though you can't see them anymore, was a lot easier in virtual reality, and it's something you can't do in regular, the regular sort of 2D media. And this was a thing that really surprised me. It was a benefit of VR that I never considered. Like, oh yeah, you as a player, you know where your hands are, and you know where your head is turned. So that's definitely interesting. Can you do something more with that? It's something that I didn't consider at first, but then in building this little experience, it's something that I discovered. Much that I discovered that being in a very high place in VR is something that is quite scary. I also built this little demo scene for myself. I ended up not doing very much with this, but it's still interesting. It's basically a foggy city. It's a very simple build out of cubes. But the player basically, all they have to do is just walk from this side to that side. And it is very, very high. It's sort of a similar kind of effect that I had with the crane application that I built for a client. Is especially new VR players will have quite the visceral reaction to this. Any sort of high, you want to add wind effects, you want to add multiple things. I added these little blocks here, these little cubes you can pick up so you can throw them down and see them fall. You maybe be able to set something up that is a bit more dynamic, just to really sell that, the idea of height. The fog here looks kind of wonky. I'm not exactly sure why, but again, I haven't used Unity to build non-Android applications for quite a while, so I'm not too used to all the new graphical stuff you can do with it, because doing fog or doing post-processing or anything like that on Android is basically not feasible. So let's see. Another thing that I was dealing with in another project was, if you're picking up objects, which this XR interaction toolkit will let you do, and you want to throw them accurately, because in this case we were doing a sort of a replay system for, what was it again? I think it was batting practice for baseball. We had a Vive tracker, which is just a loose tracking point screwed on the end of a baseball bat, like an actual baseball bat, just to see how accurately we could measure someone's swing. Because of course a swing is very fast, and we needed to know, hey, do we have enough data points to support this accurately? But the problem became okay, how do you throw something accurately in VR? And it ended up being an interesting sort of problem to solve, because every frame you can get the velocity, which is speed and direction of the player's hand, but between every frame that velocity will vary heavily, because one frame might take slightly longer to process than another, which means that a player has changed the arc of their hand in a different way. You get all these issues where throwing, doing it naively was just terrible. You couldn't get anything you threw to go where you wanted it to. And I ended up having to make a little solution for it. And this was an old project that I did. Just a little test setup where you have to throw these balls through the squares. And if you throw them through it, you get some points. And if you miss and the ball ends up in this little fail zone, like I did right here, you lose all your points. Very simple setup, but it was basically there to help exercise different ways of throwing accurately. And we used a little point system to give this to people, just random people in office and other businesses in the same building. Just go, hey, can you practice this for us? Can you just throw these balls through these things and see how well you do? The distances, it's a little difficult to see in this video, but the distance is 2 meters. In real life, you probably would miss maybe 1 in 10. This is it was supposed to be quite easy, just to see, hey, can players do this? And what we ended up doing was, if you want to throw something, you have a buffer of number of frames. You simply calculate the velocity of the player's hand over all those frames. And then when they let the ball go, you average them out. You bias towards the end. You bias the last frames heavier than the one before, because those are more important. But you average them out, all of them, and then that'll be your throwing velocity. And that ended up being okay, if you do this over about 10 frames, that's enough. Now you can throw very, very accurately. It feels very natural. The only thing then you had to play around with was the launching force. So, how the velocity of your hand translates to the velocity of the object, because we found that wasn't quite one-on-one, as you might expect. Things needed to feel a little weightier than people are used to. I think it has to do with the fact that the controller is very light in your hand. So when you're going to throw something, people expect a slightly different reaction, even if the thing they're throwing is relatively heavy in game. So we had to play around with this, but ended up working very well. Also included in this tiny demo was the blinding system. I'll go over that in just a moment. So another project that we were playing was one where this was for a VR arcade. And the idea was that the players play the game sharing both their physical space and their virtual space together. So the room they're in, both in the VR application, is the same as the room they're in when they're playing the thing, all with their headsets on. Now, this came with a couple of issues. One, the first and foremost, this means that you have 4 people that are running around in an enclosed space, all blind, and all wearing $300 headsets on their foreheads. And they're all running around each other. You can imagine that if 2 players run into one another, that is probably a situation you want to avoid as much as possible. So the big question became, how do we merge, how do we link up the virtual and physical space together? How do we make sure that these are one-on-one? And that became a very interesting problem to solve. In the end, what we ended up doing was we would take 1 controller of every player. The first player would go to a preset calibration point inside the space. We would have a little 3D printed holder for the controller. They would put their controller in there, look at it, and while they're looking at it, press a key on their right controller. And then in game, this would basically tell the game, okay, if your physical controller is now in the location, then your virtual self has to be here, because there's no other way. Because if we know the controller's physical location and rotation, we know exactly where the player's head is, we know where their other controller is, we know where everything is. So that player would calibrate, and then they would take the controller out and go away. Next player would come around, put their controller in, calibrate. And in the end, in-game, people would be able to shake one another's hand while not being able to see one another physically, because they see each other virtually, and the positions were exact to within about, I think, like 3 or 4 centimeters, with the margin of error getting bigger the further away you move from the calibration point, because any change in rotation of a controller, be it the detection from your headset or the actual physical rotational change, will become bigger of an error the further you move from that pivot point. But we're dealing with spaces, that were about like 6 by 4 meters. And the fun thing then was, because we had this physical space limited off, we could now generate a level that fits perfectly within this physical space. So the outer walls of the level match the walls of your play space. So for anyone who has I want to play this multiplayer game in a little room, they can just say okay, this is my room size. Here's my calibration point. Go ahead and generate me a level. This will fit my play space exactly. Let's go play with this. I don't have any more recent videos. This is a very, very old video about my first setup for the level generation system. But it became a lot more complicated in the end. It created doorways, rooms had to be connected. We do decoration stuff, place props along the walls and things. It really generated an environment for people to then shoot each other in. We did then run into another interesting issue. If you place a virtual wall, what is stopping the player from physically moving through this? Because our solution that I discussed before, where we simply push the entire player volume back when they touch a wall, is infeasible, because we cannot move that volume once the player has been calibrated. Because if we move that player, all the other player positions will no longer match their physical positions, meaning that people will start running into one another. So the problem became, okay, how do we prevent cheating? Well, one of the ways we did it was, if your weapon or your arm that is holding a weapon is in contact or sticking through a wall, that weapon will not fire. You can simply not shoot it while it's clipping with a wall. And then also a matter was, what if a player sticks their head in a wall? Okay, we'll blind them. Pretty simple. Problem is, what if a player then fully steps through a wall, because then they're no longer colliding with a wall. Now they've just simply stepped through, they're behind someone who didn't expect them, and they can just shoot them and then they win. It's not fair. So instead, what I did was, when a player collides their head with a wall, it registers the point that they collided with. When they then move through the wall, it'll keep checking a line between the point that they collided with and their head. And if there's still a wall in between there, it simply will go no, you've cheated. You'll get a little indication in the bottom of your view space saying you need to go back, go back, go back. But if the player doesn't, they're just blind, they can't shoot, and then anyone who sees them stepping through a wall can just shoot them. So now we're punishing the player who cheated rather than punishing the people who didn't cheat but got cheated on. So that was an interesting point to try and fix, and I think that the blinding system worked relatively well. But that's a project that's still ongoing, so we'll be making more design iterations as we go. In that project, we also came with the interesting idea about we want to do like weapon selections and item selections. How do we make this in a way, because it had to be very fast paced. We didn't want to put items in the level that you would have to pick up because it was too slow for the design. So I ended up creating this little one-handed menu. It's a menu that works entirely with a single input. You have your thumb axis represented by this gray ball. It's just simply the direction from the middle is the direction of my thumb axis. And I created a little procedural menu that just allows you to quickly click your controller to a direction, and then if you let it go, it'll pick that selection and send whatever message is attached to it to your player to handle some sort of functionality. Super simple little setup, but for a very quick one-handed input, it worked very, very well. And I ended up making a very generic version of that menu that basically works in any project. And I think it's been made part of the standard toolkit that we're using because it just works very well for many of the projects. Finally, one of the fun things, of course, about development is interesting little screw-ups. Working with that game, I had to do a two-handed weaponry. The two-handing objects in virtual reality is a very tricky thing because in real life, of course, when you're holding something with two hands, it's the object that is connecting your hands together. In virtual reality, you're holding two controllers. There's nothing actually physically connecting them unless you get one of those weird sort of mounts that you can buy. In my experience, two-handing objects is best to be avoided. But if it can't be, then it can't be. Fortunately for our design in that shooter that I talked about, it was everything was akimbo. So you always had like two different guns. You could like switch between them separately. But you do get interesting points like this where you forget to turn off your physical recoil while guns are inactive. And then you end up with what is basically ended up being a gun rave. And it was just a thing that I enjoyed looking at. Let's see. So those points I've had, let's see what else is there. Let's see, we still got 40 minutes. Right, so when it comes to benefits and caveats, one thing to really be careful of, especially for experiences that are supposed to go on for longer, we found a couple of things. One, players don't like having to duck down in order to pick something up. This gets strenuous very quickly, especially for the kind of clientele that we're working with. Two, having to keep your arms up, so having to hold your arms up to do a certain thing gets tiring quickly. And also, when we have to move the player forcefully, right? We want to move the player. Let's say the player gets on an elevator or gets on some sort of moving platform or something along these lines. This will cause nausea that is, strangely enough, even greater than when the player moves themselves around smoothly using their own controller. I think this has to do with expectation. When a player moves their own thumb axis to move forward, they kind of understand, like, okay, I'm about to move, which will mitigate some of that nausea that may come up. If we, for any reason, need to forcefully move the player, this becomes a lot greater. And one very interesting solution that I found to this problem was, for example, in an elevator or any sort of moving platform, restrict the player's view, right? Restrict it as much as possible, because there's a strange threshold between a player's brain believing that they are in the space that they're seeing, and the player's brain seeing it as, okay, I'm in an enclosed space and I'm not moving, but instead I'm looking at a screen of something that is moving. So if you ever need to put someone in an elevator or move them around, just constrict their field of view, and you'll really mitigate those that sort of nausea that you can get from it. Let's see, because man, the nausea problem really, that became much bigger than I expected ever. Like, I could go on a personal rant about this, but I've been playing around in VR for years now, and it doesn't bother me anymore. But when at work we're dealing with new clients and we're showing them projects that we're able to show them that sort of have overlap with this kind of stuff that they're looking for, the amount of people that I found that put on the headset, play around for about a minute, and then have to really take it off and need like a moment to breathe out and go like, whew, that was that was rough. They're nauseous. They want to have a break. They want to have some water. It really surprised me how much I see this. So yeah, it's only something that I can really tell you guys, like be mindful of this. Maybe it's not as bad as like with young adults, like or young like kids, because like I said in my business we deal mainly with other businesses, so we don't deal a lot with a younger audience. But I'm kind of wondering if that's the same for them. If anyone here has any insights on that, then maybe in the little Q&A at the end, I'd love to talk about it. But yeah, that's something that I definitely found. So I guess as I wouldn't call it a closer, but if you are going to be building your own virtual experience in any sort of artistic merit, really think about how VR enhances the experience. What does VR offer you that other applications can't? And then really design everything that you can around these enhancements. Really carefully consider, okay, we need to have the user make some sort of interaction. How do we make this physical? How do we make this involve the controllers, involve their hands, involve the motions that they can make in VR that they can't do anywhere else? Because it's definitely very, very worth it. And it'll make your design a lot stronger. I generally think that, working within constraints forces you to be a good designer. So it's definitely very worth it. I guess for the last little bit, I'll go over this project very quickly, just to give you a sort of broad overview of the stuff that you can find, the stuff you might be able to pilfer and use for your own methods. Essentially, we of course have the XR interaction toolkit stuff. I've built this own little player controller. The player controller is a very general sort of, okay, this thing you can equip tools in your hand on the left and right hand. Those will be initialized and taking input from the controllers pretty much immediately, which will just save you a bit of a headache of sending input from a held thing, from you to a held thing in your hand. It has some movement styles, so you can do smooth motion or support teleportation. Currently, I don't think that movement mode actually does anything. You can just do both. It has smoothing and snap turning. When you're turning your camera around, that is almost even worse than smoothly moving through a space. One of the things that I highly recommend, and I think basically any virtual reality application offers you, is snap turning. You click the axis to a side and it'll just rotate you immediately by a number of degrees. People will get used to this very quickly, and it doesn't cause nearly as much nausea as smoothly rotating, because that really, even that gets me a little sick, like smoothly turning. So this also supports like some quick snapping. It has an input handler, so anything that has to accept that input, you can just bind via that input property. It has a reference to its own XR rig, which is useful for teleporting and stuff. And then you have your right and left hand tools. You can basically stick whatever on here that you want. From code, if you overwrite this property, it'll unequip whatever's on there and it'll equip whatever on there. And those unequip and equip functions can be handled within a tool. I'll just quickly show you what that looks like, because it is useful to know. For example, the painter that we built, our little paintbrush, which is called Painter Controller. It is a tool. A tool is basically just an abstract class, which means that it defines two functions, but it doesn't have any content. It just says, hey, whatever this object is, these functions need to exist, and it has this input. And then when you're equipping it, you can just simply say, okay, well, we're equipping it, so go ahead and start listening to the on trigger click start and on trigger click end. This is also where you would do your binding for on trigger change. An on trigger change will give you a value between 0 and 1 based on how far the trigger is pulled in. So this is where you would bind that to another function. So you could do like stroke weighting. And we're unequipping it. Cool. We're just stopping to listen for those input events. And then the function we've bound to this, the on trigger click start, we have to check what device, because currently the input handler doesn't distinguish between your left and right controller. So that's definitely a point of improvement, because right now for every function that binds to that input, you have to check if the device matches the device that equipped us, the XR input device, which is left, right, or head. And then if it matches, cool, this is the controller event that happened for the controller we're bound to. So go ahead and start painting in this case, which is just do all of this. And then on end stroke, it'll stop painting. Very, very simple. So for anything you want to do that has to be coupled to a player's hand, it has to handle the input from the player. You can just use this little tool set up, and then you can just expand that very, very easily. Definitely a lot of room for improvement. This is set up very, very quickly, but I tried to make it as simple as possible just to try and get you going with something without having to dig through, miles of technical documentation and other kind of stuff. Boy, really, I went a mile a minute. Let's see what else is there. Because we have, oh boy, we have half an hour left. I don't know if there's anyone who has questions at the moment while I look through notes to see if there's more that I can grab.
I do. I have a question.
Go for it.
I'm wondering if one is not a programmer, but one would like to build like a VR experience. Is that even possible? Is it possible to do this without having a programming background?
I would say so. In the GitHub README, I've linked to a YouTube series that just says, hey, this is how you set up an interaction toolkit. That entire thing is just filling out some fields in the editor and just dragging some objects. I haven't seen any coding in those videos. There are some code examples, but you can avoid those if you want. However, of course, if you don't write any functionality yourself, you are limited to the functionalities that the toolkit offers you. Now, those are pretty broad, picking up objects, throwing them, teleporting, smooth motion, all that stuff can be done without any code, which is very nice.
Okay.
So if you have something very visual, a very visual experience with audio mixed in, and all the player has to do is just to be able to move through that space, you can absolutely build that without us ever opening Visual Studio ever, like entirely.
Okay. Thank you.
Yeah. Let's see. Was anyone else?
Yeah, I think I also have a question.
Go for it.
You showed us that example where you had that creature following you and these pulses coming out of it.
Yeah.
Yeah, and it looked very nice. Like visually, it already looked quite interesting.
This one, yeah.
Yeah, and especially I think the next one where you had it, where you were controlling this little element and it was drawn to it. Yeah, this one.
Yeah.
Very nice. Is this also something that you will make like public for people to use? Because I can really see people expanding on this system that has been set up.
Yeah, I should have this project still set up somewhere. I don't really mind sharing it. The code is old. It's definitely, I've been learning, as a technical artist, I didn't do a lot of coding very specifically until I started working at the studio that I do. So a lot of the code in this will be pretty gross, but it is functional. Yeah, I don't really mind, don't mind sharing this. Most of the work really went into the shaders. The rest of the stuff is pretty straightforward. So I'd have to see. I could probably stick it on a separate GitHub repository and then throw you the link, and then maybe you'll be able to distribute that if people want to have a look at this. I can also then stick it in as a link in the main GitHub that is already being distributed.
Yeah, that would be great. Thank you.
Yeah, absolutely. I'll see if I can grab the latest version because that'll be nice. It's a little bit more advanced than this final video. Yeah, absolutely. It was a very fun project to work on. I learned a lot of stuff about the auditory and visual senses and how they sort of work together. And I think it was also the very first project that I made that terrified me as well, because once that enemy was working in a certain way, I don't do well with horror. When it comes to horror movies is bad, horror games is bad, horror VR, I typically don't even touch. So when I decided to make a little horror game for myself in VR, that was a choice that I made, and it had consequences that I had to deal with. So it was a lot of fun to do, but at some point it actually became difficult to develop for, because the enemy that I built ended up terrifying me to live. Even though I knew exactly how it worked and could predict it quite well, it was still unpleasant. But I guess for a horror game, that might be a good thing, to a degree at least.
I have a question.
Go ahead.
How quickly does a game in VR get old? So old that you can't play it anymore?
Oh, it's an interesting question. It really depends on the game. I think this question would go for non-VR games as well. Multiplayer offers a ton of replayability, right? Because if you're dealing with people, then the experience will be different every time. So that's a great benefit, a way to enhance it. But virtual reality, for example, we found that people have a lot of fun of exploring, right? Of like figuring out different things, playing with their environment. Once they've played with everything and kind of know all the interactions and all there is to find, that replayability goes out the window. They're kind of done, like, okay, that was fun. It's where we're done now. So in that case, you would need like content updates or something along those lines. Virtual reality right now, there's basically like one really like high quality AAA virtual reality game, which is Half-Life Alyx. If you've never played it and you're interested in VR, one, I can highly recommend it. And two, it has a fantastic commentary mode where you can go through the entire game again. You'll find these commentary nodes placed in the levels. When you click on them or grab them, put them on your head, you can hear a designer talk about the various design decisions that they made about the segment of the level that you're in. So of course, it'll completely ruin the game's immersion, but usually people play this after they've played through it at least once. But you get senior developers that talk about, how they approach teaching the player certain things and how they approach getting to the game. There's a lot of stuff that they talk about that I've parroted, basically, that I've encountered myself in my own experiences. So you can also find that entire series on YouTube if you don't have you don't want to buy a $50 game just for research, or you don't have a headset. If you simply look up Half-Life Alyx commentary, you'll find a playlist of someone going through the game and listening to all the commentaries. And yeah, currently in VR, it's a pretty limited space. There's many genres that have simply not been explored at all in virtual reality. So games do definitely get old in VR, probably even a little quicker than regular games, because VR is an investment to start playing, right? People have to get up out of their chair. They have to put on a headset. They have to start the application. They can't do anything else while they're engaging with your product because you're taking up the entire space. If someone has a multi-monitor, right, they can load up a game, and during the loading time, they're watching YouTube or they're doing other stuff. In VR, you can sometimes do this, but not quite as easily. So for VR, yeah, there's more of an investment for your player to start playing. So I think that VR games probably age or get old even slightly quicker than regular games. So yeah, multiplayer, extra content updates, procedural content. There's a number of different ways to try and alleviate this. If I look at my own experience, I play in VR a lot of Pavlov because it's multiplayer. You're dealing with people. There's a lot of game modes, a lot of different things to offer. It's basically a shooter game for anyone who doesn't know. I played a lot of Half-Life Alyx, but that being a story game, it is limited in its replayability. Beat Saber, it's a great exercise tool. It's a lot of fun. It's basically a DDR style dancing game where you have to swing your arms around and flip lightsabers and hit blocks in the right direction and the right timing. And that's basically it, right? In that entire space, there's only 3 games that I would call regularly. So I think VR as a gaming space has a lot of room to grow, and it's begging for designers to really use the benefits of virtual reality and really design excellent interactions with them. And yeah, there's a ton of room if you can do something that is unique and do something with the medium that is unheard of and something that cannot be done in any other medium. You're looking at hopefully you might get some awards for it. That'll be nice. You get some notoriety. You can really start building into these experiences. So get started, get to it. It's exciting. Virtual reality is a lot of fun to do. It's definitely been my favorite platform to develop for. It's not always the easiest because you're dealing with external hardware and having to build and having to do all this stuff, and debugging is more difficult. But it's a ton of fun, and being able to be in your own space and look at a thing that you made and admire its scale, because scale is so much better in interpretation than on a screen, because you have actual stereographic depth of your eyes. your audio design and how it follows your ears as you turn your head around. It all feels so natural, and so it's probably my top favorite project that I've done at work was a project for children who are enduring long-term stay in hospital. What they basically want to do, because these children, you know, they might be immunocompromised or there might be something other that's preventing them from going outside. There was a charity that approached us and said, hey, do you guys want to build like a little magical experience that allows one of these children to stick on the headset and go for a nice long walk and be somewhere else for a while, right? Not in the gray and beige walls of the hospital, but just be somewhere magical, be somewhere different. And we as a company, we said, hey, that's a great idea. No charge, it'll be our charity towards you guys. We'll build something. That they came to me and went like, hey, we're doing this charity project. We have like this amount of time. Let's go build something. And then I ended up building this little magical park of purple trees, and there were floating glowing fruits with like little particle systems around them. And it was like this beautiful sunset with a purple sky and all this kind of crazy, you know, fantastical stuff. And yeah, the fact that when we got to hand it over and, you know, got to see some videos of kids using it and kids laughing and then playing with the fruits, because you could like bop them and they would make different tones when you hit them. And they would start playing like these little songs on them just all by themselves. It was incredibly rewarding. And a tear was shed at those videos. It was very, very nice. So you know, seeing that and seeing what it can bring and seeing how it can place someone in an entirely different virtual place and convince them that what is going around them is real and they can interact with it, being terrifying heights on a construction crane that makes them scream, or be it something as simple as hitting a little floating fruit and it makes a silly noise, has been very, very lovely. So yeah, it's easy to get into, you know, it's easy to get something going quickly. If you don't like writing code, or you don't know much code, or it seems daunting, that's perfectly okay. You can do a lot without any of it. And I think the main purpose of this little masterclass in the end is just trying to get you excited about the design challenges, excited about, you know, what benefits it can offer you in your project, how you can engage your audience on an emotional level even more strongly. Yeah, it was a little hodgepodge of different topics and different things, but in the end, virtual reality is such a broad aspect and such a broad industry. The stuff you can do with it is crazy. Just in the end, remember, you have two controllers, you have your player's view and hearing. Do as much with it what you can, and it'll be great. It was a long-winded answer to a relatively simple question, but that's me. Are there any other questions?
What kind of programming languages usually are involved in if you want to do some programming?
Unity runs in C#, which is, well, as the name indicates, is a C-based language. I find it very user-friendly. The Unity documentation has a ton of examples on how to get basic Unity things started. Things like, you know, the fact that an awake function is called by Unity automatically on the first instantiation of an object. That is followed by start. OnValidate is called by the editor when an object was changed, blah, 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 blah. It goes over all these things. I think that if you know any coding, like if you understand loops and functions and variables, you can get something going in about, I'd say like 10, 15 minutes just by going through the initial Unity tutorials. It's all, you know, Unity has got a bit of a reputation for being the shovelware kind of engine, but I think it's because it is so user-friendly, much like GameMaker was in the old day. I don't know if anyone remembers that, but Unity is extremely accessible, which means that there's a lot of people that go into it, you know, at the height of a Dunning-Kruger graph. They don't understand what they're getting into, and then they end up releasing, you know, the strange product of just a bunch of assets they've cobbled together. There's no cohesion, no design behind it, no real purpose. So people start thinking, oh, it's a Unity game, you know, oh, that must be bad. But honestly, no, Unity is, I find it a lovely engine. It has its quirks, certainly, but it's completely free. It's very accessible, and you can get going in it very quickly. Even Visual Studio, like the version of it, comes with Unity. It's like a full integrated IDE community version. It just comes with it. It's like, yep, there you go. You can get started. You can compile. You can make your own solutions, etc. It all comes with it, and it's yeah, it makes it pretty easy to get to work with. If you want to do other engines, I have done VR in Unreal Engine 4. If you're ever considering that, there's a lot of documentation and support for that as well. Unreal Engine 4 works with C++, which is a lot more technical, a lot more difficult to work with. However, Unreal Engine 4 also offers something called blueprinting. Blueprinting is basically a visual coding language. It's just attaching a bunch of nodes together to create a linear flow of executing functions. And I found it like at my education, I've graduated from game design in 2012 and then game architecture and design, visual arts a couple of years down the line. The designer group, who were people who were very good at handling interactions and presenting things to the player, but didn't write code or couldn't really do much art. They could still use Unreal Engine blueprinting to make stuff like, hey, if I press this button, this door should open. Or, you know, if I click this, the elevator should come down, or whatever. Very simple interactions with blueprinting allow you to do. And if you're not very good at coding, but you do have a strong visual mind, then blueprinting in Unreal Engine 4 may also be very good. The only thing I'd warn you for is Unreal Engine 4 is a bit heavier as a base. So if you're going to be building towards Android by using the Oculus Quest, for example, on a standalone, your visual budget will be lower because the base of Unreal Engine 4 is just heavier to render. Unity is very performant in terms of rendering. It is very, very easy to make stuff render well on Android. So it's sort of a trade-off. You know, if you're comfortable writing code and you want to prototype very quickly, I would definitely pick Unity. If you're not comfortable with code, but you do find the interesting of visual scripting interesting, then Unreal Engine 4 may be interesting for you.
Okay, cool.
I have another question. I'm wondering if you have any experience bringing point cloud files into Unity.
Oh, very interesting. I have only ever tried this once. A long time ago, I had a LiDAR scan set that I really wanted to import to see, hey, how does this handle, how we're going to render point clouds, how we're going to do this. I didn't get very far with it. However, I bet, given the fact that Unity is such a huge user base, I am 100% certain there will be someone who has done this before. And from what I see and how helpful generally Unity users are, you'll be able to find someone who has written out a guide on how to do this. I am certain.
Okay, thank you. Yeah, because I keep trying to bring point cloud files in and it doesn't work very well.
Okay, we have to look. Yeah, in the worst case, you'd have to look at like, okay, what does the internal data look like? And can I find a coder who wants to build me a little thing that just processes all the data and converts it into a format that Unity can use? Yeah, point cloud data. That would be very cool though. Like visualizing point clouds in VR, that would be awesome. So yeah, I hope you succeed. Sounds great.
Thank you.
Is anyone else?
What's your favorite Beat Saber song?
Oh boy, that's a good question. Someone uploaded a play version of Prodigy, "The Day Is My Enemy." That one slaps. That one is pretty good. It tires me out, which is usually how I know that the song does well. So yeah, it's it's a fun question.
I wish there were more songs. I'm disappointed by the amount.
Yeah, for sure. It's expensive on their end to get new songs made, and you know, actually no, I can't go into. Nobody should, you know, use certain irreputable sources to acquire songs and playlists to use in Beat Saber, because this goes against licensing and this is not allowed. So you should absolutely not do it ever.
Thank you.
You're welcome.
I spent one afternoon trying to learn how to make the songs, because Latvian songs don't exist there.
Oh,
so
yeah.
I wanted to get my mother to play the game, and so I decided that I could learn to make some songs that she might enjoy. Yeah, it was a bit more difficult than one might think.
Yeah, it's a process. I haven't tried it myself, but I have. I do know that it is a little bit involved.
If we don't have any other questions, I think we can finish up. Maybe some last words.
Yeah. Like I said, VR is a lot of fun. It's very accessible. It's becoming more and more accessible as time goes on. There's a lot of different plugins, for example, for Unity available. You know, this XR interaction toolkit, which is what I'm using in this project. There's also Steam Open VR that does require you to also have a Steam account, but it does work with all devices. There is the native Oculus integration, which only works for Oculus devices, but it is because it is specific to an Oculus device. It is a lot less bloated, so it is a lot more easy to get the terms with. It's what we primarily use in the office because our applications are so bespoke. We don't really need a massive support of other devices. So yeah, grab this project or follow some of the resources that I've linked to in GitHub and get your own going. Experiment, have fun with it. Discover the kind of problems you'll be facing that I already talked about, and consider implementing some of the solutions that I've discussed, or better yet, of course, create your own. Look at existing virtual reality games on the market and virtual reality experience, because there aren't that many that are sort of mainstream, if you can call them that. And see how they're handling certain things, see how those designers are moving through this space, and learn from them. Keep yourself up to date. Virtual reality is a very new industry, especially on a from a technological perspective, with everything moving so quickly. We're probably going to be moving entirely towards inside-out tracking, which is going to be tracking that is done from the headset outwards. So it's looking at the space around you and figuring out where you are, instead of using predetermined lighthouses, which are basically infrared pulsars that will indicate their location, and then your headset will be able to, or they will be able to see your headset and know exactly where you are, which is outside-in tracking. We're moving more and more towards wireless. That was an interesting design constraint, by the way, is that if the player has to turn themselves around and they don't want to use snap turning, they physically turn, you actually have to start thinking about the winding number, so that hey, in this scenario that we've created, these enemies or this puzzle or whatever it is forces a player to turn a lot to the left. Now they're getting a wire tangled around their necks and choking themselves. So we need to change this puzzle so that any person with a wired headset doesn't end up suffocating. And it's an interesting problem that I never considered I would face in my career as a game designer and simulation software developer. But it was one that we encountered. So there's a lot of stuff to think about that is surprising. And I'm sure that in this masterclass, I haven't been able to go over everything that I've discovered, that's for sure. And also, I'm sure that there'll be a lot more stuff that I'll be discovering in the following years. But that's kind of really also the fun of it. So I hope that you all feel more emboldened to give this a try, even for those who don't really like code. I can tell you, you can get a lot of stuff done without writing any code. And get going. I'm really curious to see what very artistic students do within this medium, because that's the point of an artist, right? It's broadening the horizons and doing the new thing. And VR is very new, so grab it, get started with it, do fun things with it. And well, of course, I'll be keeping in touch with Maya and Rogier, and seeing what they're doing and seeing what you guys are doing. And I'm very curious, like if there's another update next year, and I can see a lot of cool VR projects that people have done, I'll be very, very happy. So that's definitely something that I'm hoping for. And I think that's about it. I can ramble on for a lot longer, but I think at this point I'm not adding much value, so I'll just shush.
Thank you, and really thank you for agreeing to do this.
Yeah.
And I really enjoyed looking at your works, and thank you for preparing this little startup material for us to play with.
Yeah.
I will post the link in the chat. So anyone who wants to get it, please go ahead and find it there.
Let me just let me just commit my final changes that I just did. Just get those on the repository. Let's see, all that wood fence stuff is not important. So let me just small fixes during presentation. Oops. There we go. Okay, then the last version is on the GitHub. I'll see what Rogier asked. I'll see if I can get that sonar project. I need to find it first. It's somewhere on my computer. I haven't touched it in a while. See what state it is in. If it's still working or if some Unity upgrade or whatever messed it up. I really don't remember. It's probably a year ago or so. And then if I can get that working, I'll throw it on a another GitHub repository, and then I'll link to that one in the README of the GitHub repository that Maya will link you to. So if you have a GitHub account, you can subscribe to that repository, and then when I make a change, or in this case, update the README, I think you'll be able to get a notification, in which case you'll be able to find the Sonar project, should you be interested in having a look at that as well. Because that was a very fun one to do, and I think it has a lot of if some designer can grab it and make it into something incredible, I will be super happy, because I don't see myself working on it anytime soon. So it'd be a shame if it just, disappears in some digital drawer to gather dust.
Thank you, and have a great weekend then.
Thank you very much. You as well. Everyone else, thank you very much for your time and your attention. I hope that the update week has been wonderful. And have a great weekend. You can all relax now. I know there's a lot of information that came by over the entire week, so it's last Friday. So have a nice evening, enjoy a drink or something, and time to relax.
Thank you so much for your time.
Thank you.
Thank you.
Take care.
Thank you. Bye-bye.
Bye-bye. Let's see, can I... Yeah, there we go.
Well, I think we're here is
He's doing his other thing, right? I think
yeah, so
that's fine.
but I guess we can just leave the room for now, and we'll end the screen when we end it.
Okay. Maya, take care. I hope that the update week has been a success. From the few things that I saw and was able to attend, it was a lot of fun. So I think generally it's been pretty successful.
Thank you, and thank you for joining us yesterday. It was nice to see you there.
Yeah, I saw the notification pop up and I was like, hey, that looks cool. I want to join in. The project that I saw about the man that did a lot for the future the people running from the German regime.
Yeah.
That was very cool. Like the thing that they did in VR and like simulating these places that he lived and everything. That was a lot of fun. It was fun to see.
Yeah. That's a great little project. I haven't seen it in real life yet. I am uncertain what is the state of the project at the moment. But as we heard yesterday, they are working on the second release of this. So it is nice to see, like, we are being used in this kind of storytelling, and not as a game, but as actually kind of a bit of a learning tool, I guess.
Yeah.
Like history and such.
Yeah. It's engaging, right? And especially to like a young audience. It's an easy way to get them excited over something that if you presented to them in a book, they might consider it boring.
Yes.
Yeah. No, that was very cool. Like definitely in educational purposes, VR has a long way to go. So it was nice to see. Right then, Maya, I'm going to go as well. I'm going to go relax and let all these nerves go away now. And
Okay.
and
Thank
you have a good
you.
evening. Say hello to my brother for me, and take care.
Okay. Bye bye.
Take care.